Okay, this is just extra. I think we need some more work on this, so we're just gonna go through this and then I'm gonna give you a worksheet to do. I think you're gonna do 2 problems, but these 2 problems have a lot of parts to it. So, looking at a graph, 1, 2, 3, 1, 2, 3, and 1, 2, 3. This is a fourth of a circle from there to there. And then let's keep continuing this out a little bit longer. And let's go down 3. And let's have it go through 3, 0. And let's end it right there at 6, -3. Okay, and this is what they're going to have on the AP test. G of x is equal to, and you're going to integrate from 0 to x, f of x dx. And they say that this is f of x. Whoops, I don't need the dx part. Okay, and there's going to be lots of parts to this part on the AP test. This would be like a free response question on the AP test. So after I go through this, you'll just work on a worksheet for this section. I just think that this should be a supplement. Okay, so basically, if I integrate from 0 to wherever, depending on what my x value is going to be, from 0 to 4, from 0 to 2, from 0 to 1, and this is f of x dx, and this stands for f of x, that means that this is a velocity graph, that this is a derivative graph. And if I integrate, I get back to g of x. And when I integrate, if I go back to gx, I mean I find the area, or I integrated, or I found my total distance traveled, or I found my total of people, or whatever they're asking for. I found how far I went. All of these words would mean to integrate. Okay, so I'm just going to ask some questions. Where would the original graph, where would the original graph have a maximum? Where would the original graph have a maximum? And the original graph would have a maximum at x equals what? Well, if this is the derivative graph, all of these slopes are positive and all of these slopes are negative. It's where you go from a positive to a negative, so at x equals 3. And then you also should check your endpoints. Left is less, you have a max. If left is more, you have a min. If right is more, you have a min. And if right is less, you have a max. So we also have a max at 6. Because the right is less, you would have a max also at x equals 6. You have to check the interior points and the end points of a derivative graph. And this was taught. You have a chart that says this somewhere in your notes, in your 3-ring binder. I think it's under chapter 6 is where we learn that. So, okay, the B. Where would the original graph, or where would g of x, which would be your original graph, where would your original graph increase? Well, these are all positive slopes right here, so it would increase from a -3 to a +3. Where would your original graph decrease? It would decrease from a +3 to 6. Where would your g of x have concave up? Where would it be concave up? It would be concave up, if you remember concave up from chapter 5. Concavity is point of inflections and all that, that's your double derivative. Well, this is your first derivative. Your second derivative has positive, let's change the colors, has positive slopes to here. It has horizontal slopes, and then they have a whole bunch of negative slopes to there. So to be concave up, it's where you would have positive. It'd be a -3 to 0. Do you see how these are all positive slopes? And these are all negative slopes. So it'd go from a -3 to 0. And A, B, C, D, E. Where would the g of x be concave down? Negative slopes from 0 to 6. Where would there be a point of inflection? It's where, might as well do that one, EF, where would have a point of inflection? It's where it would have a horizontal slope. But this is hard to do because there could be a cusp right there. So we're not going to worry about the point of inflection. Okay, now comes the next part. Now they want you to integrate, and they want you to find g of a -3. So what you're going to do is you're going to change the x up here to a -3, f of x dx. What that means is they want you to find the area from 0, and they want you to change the x to a -3. So they want you to find the area from 0 to a -3. And if you look at your picture from 0 to a -3, from 0 to a -3 makes 1/4 of a circle. 1/4 pi r squared. So 1/4 pi, and the radius is 3 squared, which is equal to 9/4 pi. Okay, here comes the tricky part. This is supposed to be down here because it's smaller, and this is supposed to be up here, so there's supposed to be a negative sign. So it's a -9/4 pi. So that's the tricky part on the AP test. Okay, let's do another one. They might ask you to find g of 3. You're going to change, well, this is 0 on the bottom, but you're going to change your x to 3. And you're going to look at the shape of your f of x dx. And your shape is going to be a triangle. And the 0 is smaller than the 3, so you're just going to do 1/2 base times height. 1/2 the base is 3, and the height is 3, which makes 9/2. Or they might ask you to find g of 6. They want you to do g of 6, 0 to 6, f of x dx. From 0 to 6, the area is going to be 0, and just really quick, I can tell you why it's 0. Because this is going to be this positive answer, this is going to be the negative answer, and they make the same shape. So when you integrate from 0 to 6, it makes the same answer. If they ask you, let's see, they ask you to integrate from 1 to 2 f of x dx. And they tell you that when you integrate from 1 to 2, you get f of x plus 3 dx. What they want you to do on the AP test is they want you to break this up. They want you to integrate from 1 to 2 f of x dx plus 1 to 2 3 dx. See how you're splitting this up? So in this one, the antiderivative of 3 is 3x from 1 to 2. you don't need no picture. But when you integrate from 1 to 2, you need a picture and it makes a triangle. So this one's gonna be 6 minus 3, which ends up equaling 3 plus. This one's gonna be 1/2 the base times the height, which makes 1.5, which makes 4.5. So, and that is all the notes. And then you'll just start doing the worksheet, reading the graphs.